episode today will consist of tax chemistry review. Our first person up will be Andrea.
Hello, and today I will be explaining the periodic table. The periodic table is divided into groups. Group A1 has a charge of +1. Group A2 has a charge of +2. Group A3 has a charge of +3. Group A4 has a charge of +or -4, depending which way the electrons are going. Group A5 has a charge of -3. Group A6 has a charge of -2. A7 has a charge of -1, and this group has no charge at all. The first group is alkali metals, and they are the most reactive. Alkaline earth metals is right after that. The whole big section in the middle are called transition metals. This group before the last group are called halogens. The last group on the end are called the noble gases, and the reason they're called the noble gases is because they are basically non-reactive. They will not react as easily as anything else on the periodic table.
That was very interesting. And now we're moving along to Armando.
Alright, hello guys, I'm Armando Murphy. Today I'm talking about the two examples of ionic compounds. First is sodium chloride, NaCl, table side. And you have potassium chloride, Cl. And right here, I'm going to show you how to do a cross of the ionic compound. First of all, you have to identify the valence electrons. Na is going to be a +1, chlorine is going to be a -1. So what you're going to do right here, you're going to move this one right here, and you're going to get this one over here, and then as you see right here in the bottom, Na is going to be a negative, and the Cl is going to be a positive, and this is how you make the table side. And thank you very much. Alright, hello guys, today we're going to talk about phase of matter. Right here we got a cube, small water, and then NOS. Alright guys, right here we're going to be the states of matter. You got the solid, which basically each particle is really stuck together. And liquid is a little more separate, you know, like a divorce. And then gas is just like bam, you know, like boom, 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 hitting each other out. Right here on solid turns into gas. Deposition turns gas to solid. Melt turns solid to liquid, just like ice. Solidified is liquid to solid. Vaporized is liquid to gas. Condense is gas to liquid.
Now, let's move on to Jimmy.
Hi, yes, I'm Jimmy, and well, one of the questions we have here is, what is polar? Polar is a molecule that has one side slightly positive and the other side slightly negative. Another question we had was, why does ice float on water? That's easy. It's because it's less dense. Another question we have here is, why is water considered the universal solvent? That's because of its polarity. Anything can dissolve in water.
Now let's transition on to Jesus as he gives us his responses.
Hi, I'm Jesus Martinez, and I'm here to explain examples of saturated, unsaturated, and supersaturated, whatever. Okay, saturated is a sugar stirred in water until it dissolves. Unsaturated is still room from more solid to dissolve, something like that. I don't know. Supersaturated is water heated up and then the thing dissolves and more sugar. And then another question is, it was gasability dependent on pressure or temperature, and it is on both. Right here, both. It's dependent on both.
Now let's shift to Giovanna as she shares with us interesting information.
How does temperature affect density? The higher the temperature, the higher the density. The lower the temperature, the lower the density.
Now let's go back to Jimmy as he answers some questions.
Here we have some examples of some substances, and the question is, can it conduct electricity? Well, that's really easy. Sugar? No. Salt? Of course. Brine? Yes. Cooking oil? No. Tap water? Yes.
Now let's go to Andrea, as she has a game that is being played by a special guest.
Hello, and today our test subject here, Jimmy, will drink different substances out of these cups to determine which ones are acids and which ones are bases. Now, after you drink it and determine, I will tell you what you drank. Okay, let's get started.
That was sour.
So what was it? Was it acid or base?
Well, acids are usually sour, so I'm gonna say acid.
That's right, and that was lime juice that you drank. Okay.
What's that?
What is
It
it?
had a really bitter taste to it, so that have to be base.
Correct, and that was drink liquor. Go. You have 5 more cups.
What the hell you be putting in this, man? That was also bitter.
That was oven cleaner. It's such a fun game. Acids and bases.
Yeah, that was sour. Yeah, that's definitely an acid.
Yeah, that was lemon juice.
Really bitter. Definitely base.
Baking soda.
But yeah, that was definitely a base.
That was bleach.
No. Mm-mm. No, that was, no.
Okay, now what was that? Was that an acid or was it a base?
Oh, most horrible thing ever. That was definitely an acid.
And that was car battery. Thank you for playing with us. Now, to finish off the acids and base section, let me just say, okay. So, when mixed with water, acids will produce hydronium atoms, which are H plus molecules. Bases will produce OH negative ions. Also, when testing bases and acids, you can also use litmus paper. Blue litmus paper turns red when it comes in contact with an acid, and red litmus paper turns blue when it comes into contact with a base. Also, when placed together, acids and bases produce a salt. Okay, thank you.
Now let's go to Juan, because he has some special information that he would like to share with everybody.
This is conservation of mass. Notice in the equation above that you started with 4 atoms of hydrogen and 2 atoms of oxygen, and you ended up with 4 atoms of hydrogen and 2 atoms of oxygen. The atoms were rearranged in the equation, chemical reaction above, but they were not created nor destroyed. No atoms were lost and no atoms were added, so the law of conservation of mass was followed. For example, when heat is added to a solid but it is converted to a liquid, the number of solid molecules is equal to the number of liquid molecules. An atom or molecule may change its phase of matter with the addition or subtraction of heat, but it did not disappear.
Now let's go back to Joanna, as she has more facts that she would like to share. Go.
Some examples of physical change will be, for example, ice turning into liquid, and a chemical change is fireworks, what makes fireworks pop.
Now, to finish off our show for today, let's go back to Juan.
Alright, so this is our basic chemical equation. What we do is match the numbers together. As you can see, there's 2 ALs over here and one over here, so gotta match the numbers. 4, 2, 3. As you can see, we have 4 ALs here, 4 ALs, 6 O's, 6 O's. You balance the equation. You're done.
That was our show for today. Tune in next week for more science fun.